2 problems.
Okay, Josie, so yesterday I recorded, but it only saved like a minute and 30 some seconds or whatever of the recording. And so, and it was because my, I don't know, storage ran out of storage, I guess, or whatever. So I went and deleted a bunch of videos on my iPad, and so hopefully it's not going to do that to us today. So what I'm going to do is I have to go through example 3 with everybody here in class. So I'm going to go through example 3 with them, and then I'm going to backtrack, and I'll come back up here to the top, and I'll go through the example 1 and 2 with you. So if you want to watch example 1 and 2 first, go to the end of this video, and then come back to example 3. Whatever, however you want to do that. Oh, everybody says hi. They're so sad that you're not here.
But
we love
You're
you.
lucky you missed out on our A&P lab.
Oh, yeah.
Mrs. Boniface force-fed us and then forced us to run. Or walk. We walked. That sounded bad. We did not run.
You did not run.
I'm dramatic. Okay.
Okay, anyway, you got force fed in A and P. Sorry. All right. Okay, example 3. So what we're doing is, this is the last section of the chapter. We're doing U substitution. So substitution, definite integral, substitution. So we have to find U and du. All right, so what do you want for part A on number 3? What do you want U to be?
I have no idea.
1 minus x.
1 minus x. That sounds great. Du is the derivative of that. Derivative of 1 is 0. What's the derivative of negative x? Negative
dx.
1 dx. Okay. Let's start. Let's begin. Negative 1 dx. Yeah? Now let's start to substitute. So here's my integral. I'm going to integral. Then I've got 1 minus x, but that becomes u, but he's on the bottom. Okay. I don't like the way this is written, by the way. I'm going to put a 1 here, and I'm going to take this dx, and I'm going to shove him off the top here. All right, so he's on the side, if that helps. Okay. So 1 over u, and du is getting replaced with negative 1 dx, right? So basically, I have to divide by negative 1 over here, so dx becomes negative 1 du.
So just have the negative 1.
So I'm going to do du here, I'm going to do negative 1 there. Okay? All right, now we've replaced.
Oh, yeah.
We've replaced everything. Now what? I have to find the antiderivative.
Minus 1.
Yeah, this guy is u to the minus 1. Okay? And so I'm going to find that antiderivative. I'm going to do it up here. Negative 1 is just out in front times. Oh, wait. How do you find the antiderivative of u to the minus 1? Because this would be like 1 over 0. U to the minus u to the 0. How does that work? What is it?
It's 1.
It's no. There's a
Wait.
What is it?
No. I don't know.
It has a special. You're close. Eli's warm. Ln. Ln u. The antiderivative of 1 over u is ln of u. Yeah, so we've got negative 1 times ln of u plus c, but we don't need plus c, right? Yeah?
Negative ln of u.
No.
So negative ln of u. Okay. Now,
Plug ln of u back in.
we did,
Or ln of whatever.
we could plug in 1 minus x back in, or we could change our variables. Okay? So our variables were x equals 0 and x equals 3/4. Okay? If I plug 0 in, u becomes, like if I plug 0 in here, u becomes
Negative 0.
1.
What?
If I plug 0 in, u becomes 1? No?
Okay.
No?
What did we plug it into?
We plug it into the u and x equation. So u equals 1 minus x, right?
Yeah.
So if x is 0, u is 1. If x is 3/4, u is
1/4.
ln of u is
1/4.
negative 1.
No.
No. We plugged it in here. We're changing the variables.
Oh, shoot.
Yeah, we change the variables?
0.
Okay. So if x is 0, u is 1. If x is 3/4, u is 1/4. Okay, so now I don't replace. I don't do anything. I just plug in 1/4 and 1. Okay? So I plug in 1/4 first.
Oh, shoot. It's 1.
Negative 1 times ln of 1/4 minus what I get when I plug in negative 1 times ln of 1.
So it'd be plus ln.
So right, it would be plus ln of 1.
Okay.
Okay? What is negative 1 times ln of 1/4? What does this whole thing come out to be?
Are we just plugging it in?
Yeah. Just do a decimal. I'm pretty sure ln of 1 is 0.
I feel like that's right.
So we have a calculator.
Nope. I mean, I have one. I just don't want to get it out.
Are you charging?
Negative 1 times ln of 1/4.
Working now? ln of 1 is 0.
ln of 1 is 0? Yeah. Okay. What is negative 1 times ln of 1/4?
It was charging the whole day.
ln, where's the ln?
24 hours is still down.
Oh, ln. Of
Mine's better than yours.
4. Oh, we have the same calculator, but mine's too strong.
And is it negative?
No.
No, it's positive. 1 point.
1.3.
Oh, it's okay now.
Give me all the decimals again.
62943.
863. Negative 1.3863. Okay. Minus ln of 1 is 0. And 0 times negative 1 is 0. And so this is 0. So final answer. Final answer is 1.3863. Okay. Substitution.
629.
Substitution. Again, in here, we're doing like method 2 where we switch our limits of integration, right? Switch it from one to the other. Okay. All right, part B.
What did you eat?
Not even that much. Literally a coffee brownie. Like not like 7 Cheetos. I literally counted up 7 Cheetos because a serving size was 21. So
You did a third of it.
a third of
That's
it.
what I did.
And then I had my one singular donut and one of those Nutella things and one of the cookie things.
Oh, yeah.
What are we doing today?
I'm
in
dying.
civics? What is a Wednesday in civics?
Okay, what do you want you to be?
The popcorn.
What is a Wednesday in civics?
What should we have you to
One
be?
plus
You
e
to be.
to the x.
1 plus e to the x.
You.
Okay.
Yeah.
The derivative of 1 is 0. What's the derivative of e to the x?
E to the x.
E to the x.
We are
dx. This is beautiful. I like this a lot. Okay. Substituting. We've got our integral, so that goes first. Okay, he's done. This guy becomes u to the 1/2 power, so that's gone. And then e to the x dx gets replaced with du. I don't have to have anything out in front, right? He's just perfect.
That is so crazy. Okay.
That is awesome. Okay, now I want to take the antiderivative. U to the 1/2 is,
Two-thirds.
if I add 1, this would be 3/2.
I'm like barely processing this right now.
Okay.
Getting it. That's all about
1/2 plus 1 is 3/2, so this would be 2/3 u to the 3/2.
Yeah.
Yeah. Okay, and that's it, right? Now I have to plug my numbers in, except my numbers are not going to be 0 and an ln of 3.
Why?
If x is ln 3, and x is 0, I want 1 plus e to the x. So u will be 1 plus e to the ln 3,
Oh my god.
and u equals 1 plus e to the 0. Okay, this comes out really nice, guys. This comes out really nice. Look at this. What is e and ln?
Oh, 3.
They
1 plus
cross
3.
out.
This cancels out. 1 plus 3, u is 4. E to the 0 is
What just happened?
1.
1.
okay,
So
yeah,
1 plus
okay.
1 is
2.
2. So my limits are from 2 to 4. How
I was
nice.
just gonna plug that into my calculator.
I was gonna
Isn't that
too.
embarrassing?
We don't need that.
You know what? I would have.
Okay.
I was too, but I
You
didn't
know
know
what?
what the E button is on
Okay.
this one.
Alright.
So I plug in 4 first. 2/3 of 4 to the 3/2 power, whatever that is, minus what we get when we do 2/3 times 2 to the 3/2 power.
Minus
Okay. 4 to the 3. Oh, I don't want.
2. 2 then. 2. Oh, it's 3. Oh.
Girl, what?
Oh, what?
Who posted what?
The prom royalty on Facebook.
And did she not do something right?
She posted 3 junior boys
Should I post?
instead of 4. Who
She
did she
didn't
not post? Billy?
Should I post Eli?
Oh,
Me?
Eli. Yeah.
She handed me the roll.
Or should I put you on?
She didn't put you on there.
Hey, I got the answer.
Okay, what's the answer?
3.4477.
3.4477.
That's the final, or is that
Is that the final
the
final?
first one?
That's the first one.
Oh.
I'm joking.
Oh, okay. Okay, 3.4477. Okay. Good.
What is Reese on
Okay.
today?
I love it.
Beautiful. All right. So, do we know what we're doing?
Ate too much.
No.
All right.
Sugar.
You people here in class,
I know.
here is your task.
Work
These 6. Get those
Can I go
6
get
done
my
so
book?
tomorrow we can turn it in and we can move on to the next thing.
No.
I gotta get my book.
No, tomorrow we're not
Next
doing
thing is a
anything.
review.
Tomorrow we're not doing anything.
Tomorrow we're not.
Oh shoot, now we're not doing anything tomorrow.
I won't.
This isn't mine.
Except we might turn in homework tomorrow. If there's people who still
I
have
won't
questions.
Be here tomorrow.
I'm gonna have fun.
Yeah.
Are you gonna put me on the down list? Okay, can we like
Yeah. Are you gonna put us on the downs list, Coverture?
No, you're not missing 4 assignments
Yay!
before you leave for a huge school event.
They're missing 4.
Oh, they were already missing stuff before they left.
Yes, that's why. It wasn't because they didn't turn anything in before, like it was due. It was because they were down before they left.
That is hilarious.
Yeah.
I don't, okay, I can see one of them, but Kyle, why was Kyle
Yep.
not turning his work?
But
It's right there, obviously, during stats, and I'm like, Kyle, you haven't done that yet? He's like, I have one day of the week that I do homework. It's like, okay, well,
How do you just do
one
one
day
day?
of the week.
He does other stuff.
Okay, I gotta finish recording for Josie. So work on your homework. I gotta finish recording for Josie. Okay, Jose, here's how this works. We're doing substitution. You just keep doing what you're thinking, okay? All right, here is how this works. Method 1, method 2, we're doing substitution and we're solving this stuff, okay? So here's what we've got, all right? Substitution, we want to pick the stuff to set equal to u that is in the inside. So we've got x squared plus 1. That's my inside piece. And then if I'm doing du, it's the derivative of this stuff, okay? So du for that will be 2x, and then the derivative of 1 goes away. So it's 2x dx is the derivative of that stuff, okay? Now I start to substitute, okay? So I'm going to substitute right here in the middle, okay? Method 1, method 2, we'll eventually put stuff here and here, but for the first part, most of the stuff stays the same. Now we're starting to substitute. So I've got my integral symbol, he gets copied down, okay? Now I start to plug stuff in. So u is x squared plus 1, so this guy becomes u. So this is u to the third power, that's this stuff. Okay, then I have x dx. I have x dx that needs to be replaced, but I don't have a 2 there. So I'm going to move the 2 to the other side, and it's going to be 1/2 du is x dx. So I need a 1/2, and I need a du. Okay, if you need to stop and look back at that, that's totally fine. So there we have everything done, and it is replaced and all that good stuff. Okay, now we're going to find the antiderivative of u to the third. Okay, so this 1/2 is just chilling, times, this would be 1/4 u to the fourth power. Okay, and normally we would have a plus c on the end, but we are going to plug in limits of integration, and so we don't need plus c. So this is really 1/8 u to the fourth power is what that looks like after I multiply those through. Okay, method 1. For method 1, we replace this u and we plug this x squared plus 1 back into u. Okay, so this would be 1/8 times x squared plus 1 to the fourth power. Okay, and now I go through and I plug in my numbers, and my numbers from here are 0 and 2. So 0 and 2. All right, so I've got 1/8 times 2 squared plus 1 minus, to the fourth power, minus what I get when I do 1/8 times 0 squared plus 1 to the fourth power. Okay, now, I don't know if you remember from before, but we've done stuff before where like 0, when we're plugging 0 in, it's really nice because it just ends up being 0. That is not the case when we're doing substitution. This guy won't always end up coming out to be 0, so be careful of that. All right, this guy right here, if I start to do this stuff, 2 squared is 4 plus 1, this is 5, and 5 to the fourth power is 625. And I have 1/8 of that. Okay, 1/8 times 625 is, I'm just going to say 625 over 8, because that's over 1. So 625 over 8 minus 0 squared is 0, plus 1 is 1, and 1 to the fourth power is 1, and so this is just minus 1/8. Okay, and then if I subtract those, this was going to be 624 over 8, and that comes out to be like 78 or something like that, I think is what it is. Okay, now that's method 1. Normal, straight through, all the way, okay? But instead, what we could do is method number 2, and that just means I get to leave this as 1/8 u to the fourth power, okay, which is what we got for our antiderivative. And what I'm going to do is I'm going to do something called changing. I'm going to change the limits of integration. Change the limits of integration. So before, my numbers were 0 and 2. So fx equals 0 and x equals 2. I'm going to write them like that just so I can remember which one's on the top and which one's on the bottom. If x is 0 and x is 2, and I know that u is equal to x squared plus 1, because that's what I set my u as right here, that guy, okay? I can say u equals, and I can switch my limits. So if x is 2 and I plug 2 in here, 2 squared is 4 plus 1, u would be 5 in that case. If I plug 0 in, 0 squared plus 1 is 1. So now instead of replacing the u and doing all that stuff, I'm going to just evaluate from 1 to 5 instead, going with my u limits now. And this makes it just a little bit cleaner because now I do 1/8 times 5 to the fourth minus 1/8 times 1 to the fourth, okay? And it's gonna, like, the work is gonna look similar to what we did over here, right? It's just like less messy. So 5 to the fourth power is 625, times 1/8 is 625 over 8, right? Again, minus, this is 1, So minus 1/8, which is 624 over 8, which is 78. Okay, so method 2 just involves like switching from x's to u's, and then you don't have to replace this u and plug it back in. So that's kind of how that works. Okay. All right, if you need to pause and digest that, go for it. I'm going to go through and I'm going to do A and B, but I'm going to leave my work here, and I'll just write over top of it so that you can see it, because some of the stuff is kind of messy. So, here we go. I'll erase some of this stuff. Yeah, I'm going to erase some of this stuff.
Will you let me know when you have the first one done?
Do I want to erase this stuff? Yeah, I'm going to erase some of it. Okay. Yeah, I'm going to erase some of it. I'll just leave the answer. How about that? Okay. Yep, that's what we're going to do. Okay. All right, so part A. We have to decide what our u is going to be. And so one thing I see here is that this fifth power right here, that means sine of 2x, that whole thing to the fifth power. That's another way of writing it. So that means that, or that's maybe an easier way to see that that's what my u should be. Okay, so u, I'm going to say u is sine of 2x. Okay, then du is the derivative of that. Okay, and the derivative of sine is cosine. So I have cosine of 2x, except I have to do kind of like the chain rule where you take the derivative of the outside, which is sine of 2x, but then I have to multiply by the derivative of the inside. And the derivative of 2x is just 2. Okay, so it's kind of like the chain rule, derivative of the outside, then derivative of the inside, and then that's dx. Okay, and now I'm going to start to substitute. Okay, so I've got my integral symbol right here, this guy. Okay, this right here is like sine of 2x to the fifth, but since we called that u, this is now like u to the fifth. And then I've got cosine of 2x dx, right? And cosine of 2x dx is true, except I've got this extra 2 in there, which I need to bump to the other side. So I've got 1/2 du equals cosine of 2x dx, that stuff, okay? I bumped that 2 to the other side, that extra 2 that I don't need. Okay, and now I do my derivative, so, or my antiderivative. So 1/2 times this guy becomes 1/6 u to the sixth, okay? And that's my antiderivative. So I've got 1/12 u to the sixth power. Okay, then when we did this yesterday, the other guys liked the method 2 where you're just doing like a little bit less work, okay? And so I'm going to switch my limits. So if x equals and x equals, here are my x's. If x was 0 and pi over 8, okay, that came from right here, then I need to switch them to what the other one is, okay? So u equals and u equals, okay? My u is sine of 2x, okay? So I'm going to go sine of 2 times x and sine of 2 times x, okay? And then I'm going to figure out what that is, okay? All right, sine of, I'm going to do the bottom one first. Sine of 2 times 0, that's sine of 0. And on your unit circle, if you want to look on your unit circle, sine of 0 is 0. Okay, so u will be 0. If x is 0, that means u is 0. Okay, fine. This one is 2 times pi over 8. And 2 times pi over 8 is pi over 4. So if you look on your unit circle for sine of pi over 4, that is the square root of 2 over 2. So if I switch my limits, I've got the square root of 2 over 2, and 0 is what I'm plugging into my antiderivative, because I switched those limits. That's changing the limits of integration. That's this process right here, okay? Again, if you need to pause, go for it. All right, I'm going to keep on going. This guy, we're going to plug in square root of 2 over 2 first. So I have 1/12, and I have the square root of 2 over 2 to the sixth, minus 1/12 times 0 to the sixth. Okay, and what we did, you can type that all into your calculator if you want to. Like a 0 squared is going to make this whole thing 0, so that's really gone. Like this, we don't care about. But then we did some stuff over here, and we end up with 1/96 is our answer, or you might have it come out as a decimal in your calculator, but that's what he will end up being. Okay, so that was problem number 1. Then problem number 2. Problem number 2 is this guy, is this one, okay? And we have to decide, so we've got like 2 parts here. And I have to figure out like which one am I gonna have u be? Well, since this one is to the 9th power, I'm gonna say u is gonna be equal to x minus 3. That's what I'm gonna do, okay? That way I can make this u to the 9th instead, okay? and then du equals the derivative of this. And the derivative of x is 1, and the derivative of 3 goes away, so this is just 1 dx. Okay, weird. So I'm going to start substituting. So I have my integral symbol goes first, so he's gone, okay? This guy right here, since this is u, this becomes u to the 9th power. I'm leaving a little bit of space so that I can put some stuff here. And then I have, so that's gone. And then I need to figure out how to replace this guy and the dx. Well, I know that dx becomes du, so I'm going to replace the d with du, and so this guy's gone. But I still have this 2x minus 5 there, and that's causing problems. So I can't just leave it as 2x minus 5 because then I have an x here and a u here, and that's not going to work. So what I have to do is I have to change this x, I have to change this x to become u. So I know from here that u is equal to x minus 3. So if I try to get x by itself and I bump the 3 over, u plus 3 is equal to x, right? U plus 3 is equal to x. Now I'm going to take this and I'm going to shove it in there. So I have 2 times u plus 3 minus 5. Okay, I just plug that in there and then I can simplify. 2 times u is 2u. 2 times 3 is 6 minus 5. This guy will become 2u plus 1. Okay, because the 6 and the 5 become 1.
Yeah.
Gross stuff. Okay, if you need to pause and go back or do whatever, you just do whatever you need. Okay, now the really nice thing is that this u to the 9th power, he can be distributed there, right? So this is my integral. 2, that will become 2u to the 10th power, right? This is u to the 1st and u to the 9th. Then if I multiply them here, that's just plus u to the 9th. And then I've got that stuff du. Okay, all right, so I distributed the u to the 9th through. That's it. Okay, now I do my antiderivative. Okay, so this 2 is just chilling out front times 1 over 11 u to the 11th. Okay, plus this would be 1 over 10 u to the 10th power. Okay, and that's how that works. Okay, so really if you want to clean it up a little bit, 2 times 1/11 is 2 over 11 u to the 11th plus 1 over 10 u to the 10th. Okay, and then I'm going to figure out what I'm going to plug in for those guys. Okay, so I'm going to go back to my limits. My limits are originally 2 and 5, but that's when I was in terms of x. Now I'm in terms of u. So if x equals and x equals, if x equals 2 and x equals 5, u equals. Okay, I'm going back to this equation right here. If x equals 5, I'm doing 5 minus 3 equals 2. So u is 2 in that case. If I plug in 2 here, 2 minus 3 is
then the derivative thingy.
negative 1.
But you
So
have to-
instead of plugging in
to
2
the
and
eighth.
5, I'm going to go negative 1 and 2. Okay?
Oh, yeah.
Where's the 9th?
And
Where's
so
the
what
You-
we
I-
did
sorry, I
here
took the
then
derivative
was we
on
plugged,
antiderivative
so
on
this row right here is plugging 2 in. 2 goes here, 2 goes there. So
127.
2 over 11
Negative.
times 2 to the 11th
Well, I need
plus
that. Negative
1 over
127
10
to the
times
9th.
2 to the 10th.
And then
Okay,
you
that
plug
whole big
in-
chunk, and then subtract what you get when you plug in negative 1. 2 over 11, I'm replacing
Is it
negative 1 to
2?
the
I don't have
11th
a negative 2.
plus 1 over 10
No,
times
no,
negative
it's-
1 to the
I think
10th.
it's positive.
And we simplified some stuff, but then we just ended up putting it into our calculator
No,
and we
it's
do all that
negative.
stuff and we get 474.84.
Because on one of mine I have it
Okay,
being positive
is what we
and one
get,
of them I have
all
being
right?
negative.
So
The
kind of a
top is
messy
negative 2, the
stuff,
bottom is
especially
1.
when these equations are kind of gross.
Yeah, it is.
But that's the whole process, is
4
that you're
minus
doing the
3x.
antiderivative, but you're doing it with substitution. And method 2 makes it kind of nice
no, I
because
was
you're just
talking about the
taking
problem.
and changing your limits of integration. So if x is this, then
Yeah,
that means
yeah,
u is
yeah.
this, because that's what we said our u
And then I
equal
plug
to.
that back into the.
Okay, from the equation. So
What do I
hopefully
plug that
that
back
helps. You can sure
So the-
email me or text me and
the
let me know if
127
you have any
to the 9?
questions. But this is the homework assignment that we used for, or that we did for 5-9. Those 6 problems. Okay, and
Oh, okay.
yeah,
See, I get lost
there you
if I
go.
don't follow my paper. I was trying to do